This is section 10.6, volume of prisms and cylinders. These are the objectives. You can pause to read, and there's only one vocabulary term, which is just volume. Let's go to the next slide. Follow along. The volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. So volume is very different than surface area. Volume is basically how much, picture it this way, how much sand would it take to fill whatever object you have. Surface area is just like paint. I can clarify this even further in class if you like me to. I want you to read this and look at this picture. Follow along. It says Cavalieri's principle says that if two three-dimensional figures have the same height and have the same cross-sectional area, and this is the cross-sectional area, this and this are the same and the same height at every level, then they have the same volume. Okay, and you can read this. This will make a little more sense once I show you another slide. Let's move on to the next part. This is a formula. You're familiar with something like this. Now we're going to be computing volume, as you may already know. The volume of a prism with base area B. So if the area of this is B, the volume of this prism is going to be whatever the area of the base is, B, times the height. In the same manner for this oblique prism. And you know these two. A cube and the volume of a right rectangular prism. And notice that the same formula applies for both of them. Let's move on to the next slide. Number 1 says find the volume of a right regular hexagonal prism, round to the nearest tenth if necessary. So the first thing we're going to do is we're going to find the apothem and compute the area of the base. This is a hexagon, so you have to go through the steps of finding half the center angle, and once you have the apothem, find the perimeter, multiply the perimeter times the apothem and divide it by 2, and that's your area. And you did this on the previous chapter, so it should be familiar. You should be familiar with those steps. You should notice that the apothem is 4.5 radical 3, and I'm actually using the 30-60-90 properties of a right triangle. That's why the area of the base is 1/2 the apothem times the perimeter, because it's 6 sides. 6 times 9 is 54. Simplify this. This is what I get. 121.5 radical 3 square feet. Now to find the volume, since I already know the area of the base, all I need to do is multiply times the height, and that's my second step. And here's what I have. Volume is equal to the base times the height. Go through the math, and this is what you get. Here's number 2, says find the volume of the prism. So the first thing you're going to do is find the volume of the base, which again, we're looking at this rectangle, and the area is length times width, which is 36. Once you know that, all we need to do is multiply the area of the base times the height, which you know that it is 6. So volume is equal to 6 times 36, and the answer is 216 cubic centimeters. Let's go to the next slide. Here's the next formula. This is how you compute the volume of a cylinder. So follow along. Says the volume of a cylinder with base area B and radius R and height H is volume equals whatever the area of the base is times the height. And again, these are same formulas. Now, whatever the area of the base is, in this case, the area of the base is a circle. That's why you see pi r squared times whatever the height is. And again, the height is always perpendicular to the base. And the next thing that you're going to see sort of explains Cavalieri's principle with cylinder, and it makes a little more sense. Follow along. This Cavalieri's principle also relates to cylinders. Notice that the two stacks have the same number of CDs, so they have the same volume. Let's move on to the next slide. It says find the volume of a cylinder, give your answers in terms of pi and round it to the nearest tenth. So the first thing you're going to do, this is the formula, pi r squared times the height, or the area of the base times the height. So notice that the radius in this case is the distance from here to here, which is equal to 9. We don't use 18. So that's why you see the following: 9 squared times 14 times pi. If you leave it in terms of pi, this is what you get: 1,134 pi cubic inches. If you round to the nearest tenth, you have to work with the pi that is built into the calculator, or use 3.14, and this is what you get. Let's move on to number 4. It says find the volume of the composite figure, round to the nearest tenth. Now, this is a composite figure. The way that you're going to be looking at this is going to be a little bit different. So first, let's look at this. Let's find the area of the base. The area of the base is not going to be what you see down here. It's actually, let me change the color, it's going to be this. This is going to be your base. And then your height is going to be the 4. So to compute the area of the base, which represents these two shapes, which is sort of like a composite figure, it's actually a rectangle, which is the 8 times 4. This rectangle, and then the triangle, which is what you see here. So this is the area of your base. With a little bit of math, you should agree with me that 8 times 5 is the area of the rectangle. Now, the area of this equilateral triangle, I'm using the formula that is s squared radical 3 divided by 4, and this is what I get. I'm going to simplify this in a little bit, and this is what you get. 8 times 5 is 40, and then this just becomes 16 radical 3. And so this is the area of the base. The height is 4. So to find the volume, all I need to do is multiply the area of the B times the H, which is 4, and that's what I did. And you get 160 plus, if you distribute the 4, 160 plus 64 radical 3. If you round to the nearest tenth, this is what you get: 270.9 cubic centimeters. Let's go to the next slide. Here's number 5. It says find the volume of the composite figure, round to the nearest tenth. Let's first find the volume of the square prism, which means that we have to find the area of, let me change the color, of this base, which is actually squared, but I'm not going to look at it as a square. I'm actually going to look at it as a rhombus, and I'm going to use the formula d1 times d2 divided by 2, and I'm going to multiply that times the height so I can get the volume. So 6 times 6 divided by 2 gives me the area of the square, or if I look at it as a rhombus, times the height, which is 5, and it gives me the following. So this is the volume of the square prism. Now let's compute the volume of the cylinder. So all I need to do is use that formula, pi r squared times the height. So pi, the radius is 3, and then the height is 5. I square the radius, simplify this, and I get 45 pi. So the volume of this composite figure is basically the the volume of the cylinder, and I'm going to take away the volume of the prism. And that's what you see here. The volume of the composite is the volume of the cylinder minus the volume of the prism, square prism. And then I have 45 pi minus 90, and if I round to the nearest tenth, is 51.4 cubic centimeters. Let's go to the next slide. This is the exploring effects on change in dimensions. Now we're going to be talking about volume. And if you pay attention to what you saw on the answers on some of these problems that were computing volume, the units were always centimeters, cubic, whatever units. Okay, so this is going to change what we're going to do, and you should be able to see the shortcut in just a little bit. This is actually doing it the long way. The original dimensions, this will be the volume. If the dimensions are multiplied by 2, why? Because that's what double means. This is what you get. And notice that this is, if you multiply 18 times 8, you get 144. But if you want to do it this way, you have to actually compute the volume of the original dimensions, volume of the new dimensions, and then figure out what the factor you need to multiply this by so you can get 144. Or all you need to know is that this represents the number 2. And since we're talking about volume, and the dimensions are always cube or cubic, all you need to do is you take that number and you raise it to a third power. And this is how you get 8. So in other words, just by looking at doubled, and since we're looking at describing the effect on volume, just take this number and raise it to the third power. And that's how you get this. And if you do that, you can avoid all these steps. And that's what we're going to do on the last problem on this video, which is number 7. It says the radius and the height of the cylinder are multiplied by 2/3. Describe the effect on the volume. Again, here we're talking about volume. So I'm going to take this factor and I'm going to raise it to the third power. Without doing any work, I can answer this question. And all I need to do is just basically say what I have here. When the radius and the height are multiplied by 2/3, the volume is multiplied by 8/27. How did I get this? I raised 2/3 to a third power and I get 8/27. And we're done. This concludes video 10.6.